Last chapter we drew Oracle as one instance connected to one database. Now I'm going to blow that picture wide open because in modern Oracle, one instance can hold many databases at the same time. That's multi-tenant, and it is the single most defining feature of Oracle 19c. Interviewers assume you can talk about it fluently, so by the end of this chapter you'll be able to. The whole thing comes down to one image, one building, many tenants. Let's build it. So why did Oracle build this? Rewind a few versions. Back then, every database was a completely separate, self-contained unit. If you wanted 10 databases on one server, you paid for 10 separate sets of memory, 10 sets of background processes, 10 of everything, a mountain of duplicated overhead. Multi-tenant exists to kill that waste. The idea is simple. Share the expensive infrastructure, the instance and the system files, one time, but keep everybody's actual data cleanly separated. Pay the overhead once instead of once per database. Hold on to that motivation, because it explains every design choice that follows. 2 pieces of vocabulary, and you must keep them straight. The container database, almost always just written and said as the CDB, is the single instance plus the one shared set of system files. It's the container. Inside it, live pluggable databases, written as PDBs. Here's the beautiful part. To an application, a PDB looks and behaves exactly like an ordinary standalone database. The app connects, runs its queries, and has absolutely no idea it's actually sharing one instance with a dozen sibling PDBs next door. CDB is the container. PDBs are the databases that plug into it. If you remember one analogy from this whole course, make it this one. Interviewers hear it and immediately relax because it proves you actually get it. The CDB is an apartment building with shared plumbing and shared electricity. Each PDB is an apartment, and each tenant lives completely independently. The tenant in 4B has no idea who's in 2A, but they're both drawing from the same water and power lines running through the building. That shared infrastructure is the entire point. It's why multi-tenant saves so much memory, and it's why administration gets simpler. You service the building once instead of visiting every single apartment. Patch once, backup once at the building level. Let's step inside the building. Every CDB always contains a few specific containers. First, the root, named CDB $root. Think of it as the building management office. It holds Oracle's system metadata and the common users that apply across the entire CDB. Second, the seed, named PDB $seed. It's a read-only template. When you want a new PDB, Oracle stamps a fresh copy from the seed, the same way you'd duplicate a template file instead of writing a document from scratch, which makes creating databases incredibly fast. And third, your own user-created PDBs, which is where your actual application data lives. Big rule, you never put application data in the root. Root is for system-level stuff. Your data goes in a PDB. Because some things belong at the building level and some at the apartment level, Oracle splits users and roles and privileges too, into 2 kinds. A common user exists up in the root and in every PDB at once, and its name must start with /# like cetman. A local user exists in just one PDB, and that's the normal case for your everyday application accounts. Same idea carries over to roles and privileges, which we dig into properly in Chapter 11. For now, just anchor on the split. Common spans the whole building. Local stays in one apartment. Here's a trap interviewers absolutely love, because it's a 2-second tell. They'll ask, why does a common user's name have to start with /#? A lot of people freeze, because they learn the rule, but never the reason. The answer is simple. The /# prefix marks the account as common. It lets Oracle, and any human reading it, tell at a single glance that this user spans every container, rather than being a local user tucked inside one PDB. It also keeps common and local names from colliding. So don't just memorize the rule. Say the reason out loud. /# means it crosses containers. That one sentence separates you from the pack. Since one instance now hosts many PDBs, you have to be deliberate about which one you're actually in, This trips up beginners constantly. You connect to a specific PDB through its network service name, which the listener manages. That's Chapter 13. Once you're connected, the command showConName tells you exactly where you are. Here it says CDB $root, so I'm up in the root. To drop into a PDB, an administrator runs ltar session set container equals the PDB name, and now showConName confirms I'm inside sales PDB. Build the habit of checking con name before you run anything destructive. Running the right command in the wrong container is one of the most common and most painful beginner mistakes. Here's what elevates this from a beginner definition to a senior level topic. Multitenant unlocks a few powerful operations you should be able to name on demand. 1. Clone. You can copy a PDB to create a fast, isolated environment perfect for spinning up a test or dev copy in minutes. 2. Unplug and plug. You can unplug a PDB into a portable set of files, carry it to a different server, and plug it into another CDB. That's how you move a database between machines. 3. Patch once. Because the infrastructure is shared, you act on the CDB and patch or upgrade all its PDBs in one shot. You service the building, not every apartment. These three are the reason companies actually adopted multi-tenant, and being able to explain the why is what signals you've really worked with 19C. Let's prove the whole picture with two commands you'll run all the time. From the root, query $PDBS, and you get every PDB in the building along with its open mode. Look at the list. The seed is read-only, as always. SALS PDB is open read-write and serving traffic, and HRPDB is only mounted, not open yet. That's a key detail. PDBs open and close independently of each other and of the CDB, which we cover in Chapter 5. The second view, CDB_PDBS, is the persistent catalog of your pluggable databases and their status. $PDBS for the live state, CDB_PDBS for the durable list. Between them you can see the entire container layout at a glance. Let's lock it in. A CDB is one instance plus one shared set of files, and it holds many PDBs. The picture is the apartment building, shared infrastructure, independent tenants. Inside every CDB you've got CDB $route holding system metadata, PDB $seed as the read-only template, and your own PDBs where the application data actually lives. Users split two ways. Common users span every container, and their names start with C##. Local users stay inside a single PDB. The senior level operations to name are clone, unplug, and plug, and patching the whole CDB at once. And the trap, C## marks an account as common so everyone can tell at a glance that it spans containers. So we've shared the building. Now let's meter the power. If the CDB is the shared infrastructure, then memory is the electricity running through it, and it's where a huge amount of Oracle speed comes from. In the next chapter, we crack open the instance itself and look at how Oracle uses RAM, the big shared memory area that every session draws from, called the SGA, and the private memory each individual session keeps for its own work, called the PGA. Get those two straight in performance tuning. Later in the course will make total sense. That's Chapter 3. I'll see you there.